Hello online beavers, welcome to our lecture video. In this lecture video, we'll be talking about principle of superposition, what is principle of superposition and what is the use of principle of superposition. So as you can see here in the figure, we have a steel bar which consists of three sections, section 1, section 2 and section 3, and each section consists of length L1, L2 and L3 respectively. So let's see the section 1. So as you can see here in section 1, there is a force of P1 acting at the left, and there is a force of P1 acting at the right, and due to the presence of these forces at section and due to the presence of these forces at section 1, there is a deformation del 1. Deformation del 1 is caused at section 1 due to the presence of force P1. Similarly, if you move on to section 2, you can see there is a force of P2 acting at the left and force of P2 acting at right, and due to the presence of these forces, a certain deformation del 2 is caused. Similarly, in section 3, force P3 is acting at left and right, and due to the presence of these forces, deformation del 3 is caused in section 3. So so let's say if I had to find the total deformation of this steel bar due to the presence of these forces P1, P2 and P3, let's say if I denote total deformation by del, then the total deformation would simply be equal to the deformation of section 1 plus section 2 plus section 3. So simply if I had to conclude, the total deformation of this steel bar will be equal to the deformation of section 1 plus deformation of section 2 plus deformation of section 3 due to the presence of these forces P1, P2 and P3. So mathematically I have simply written that the total deformation of the steel bar del equals to del 1 plus del 2 plus del 3. So del 1 plus del 2 plus del 3. So this is what basically the principle of superposition is. So the use of principle of superposition simply is that if I had to find the total deformation of the steel bar, I will simply add the deformation of the individual sections of which the bar is made up of. So now for the statement of principle of superposition. Principle of superposition states that when a number of forces are acting simultaneously on a body, the resultant total deformation or strain is the algebraic sum of the deformation caused by the individual forces. So this is what I basically said before. And if I had to mathematically write principle of superposition, firstly I am considering a bar of area A. Let's consider the area of this steel bar is A, and the modulus of elasticity is E. Then the total deformation del, the del which is the total deformation is equals to deformation of section 1 del 1 plus deformation of section 2 del 2 plus deformation of section 3 del 3, and del 1 is equal to P1 L1 by A plus P2 L2 by A plus P3 L3 by A. So let's say that if there were n number of sections, then we had to continue this till P and Ln divided by A. So let's say equals to A. So if you have any confusion regarding how this del equals to PL by AE, so here I have written del equals to del 1 equals to P1 L1 by AE. So let me tell you how this is derived. So what we have from Hooke's law is, stress is directly proportional to strain. Stress is directly proportional to strain E. So this is equal to stress is proportional to strain. Stress is proportional to strain. Stress equals to E, where E is Young's modulus of elasticity. So we have strain equals to P by area. P by P, where P is force divided by area. E remains same. E is del, where E is strain. Strain we can write as change in length divided by original length. Then del L equals to PL by A, where DL equals to change in length or deformation. So simply del L equals to PL by A. So this is how del equals to PL by A. So this is what principle of superposition is all about. In the next video we will be solving various problems related with principle of superposition. So if you like our content, do subscribe the channel, and if you have any queries, do comment down below. Thank you.